Now, what is the connection to physics with this model? Now, instead of having this on and off, you may have two spins. So 0 and 1 may denote two kind of spins. So it can be positive and negative, for example. Okay. Now, what can happen is that you start with, say, all negative spin particles, and then you apply some kind of field, external field. Depending on the situation, it can be an electric field or a magnetic field or whatever kind of field that you need. And this field is, of course, going to change the configurations of these particles, or spins of these particles. Now, suppose the spin changes in this random fashion, in this on-off process kind of fashion. Each time, one of the particles is chosen at random and the spin is altered, the spin is changed. If it's plus, it becomes minus. If it's minus, it becomes plus, and so on. Then the dynamics of the spin configurations is going to evolve exactly like this on-off process. So this will be a Markov chain that exactly is this on-off process. So therefore, this is a very useful model in physics, but I must say that this is a very simple model, very simplistic model. One can introduce more difficult models where there is, more complication in the dynamics, but this is a very simple dynamics. Now, one of the questions that one can ask in physics is, say, you start with all negative spin particles. And then, of course, you apply this on-off process because of the external field. And then you can ask, what is the expected time for all the particles to have positive spins? This is a question that one can answer using Markov chain theory. So in other words, what I'm asking in this context is that if you start with all lamps off and apply this on-off process, how long do you have to, on an average, how long do you have to wait to get all the lamps switched on? So what is the expected waiting time for all the lamps switched on, becoming on? Okay, anyway, we'll come back to this example later. But as I said, this is a simple random walk on Z2 power D. In fact, instead of writing 0, 1, we wrote Z2 because we wanted to emphasize on this group structure. So Z2 power D is a group, right? So in other words, what I'm saying is that the last 3 examples actually fall under this general category called random walks on groups. We are not going to study the general random walks on groups in this course, but we'll see examples. We'll see enough examples to have some idea on the subject. So far the groups has been abelian. So we started with Z and then generalized to ZT. Then we also looked at the group Zn. So this is the group of integers modulo n, addition with addition modulo n. And then we looked at Z2 power D, this d-dimensional discrete hypercube. All of these are abelian. Of course, there can be non-abelian examples as well, and we'll see one such example. Namely, look at the simple random walk on the free group of rank 2. Okay. Another source of random walks is card shuffling. And this actually is a random walk on a non-abelian group. So if your deck of cards has 10 cards, okay, then card shuffling, any scheme of card shuffling will give rise to a random walk on the group Sn. There, of course, the questions are more difficult, and the questions typically are like this. What is the what is the expected time, or what is the time after which the pack of cards would become random, in the sense that all possible arrangements of the cards become equally likely or close to equally likely. These kind of questions have to be answered. These can be also answered using Markov chain theory, but we are not going to do that in this course. In particular, we are not going to talk about random walks on SN or card shuffling at all in this course. However, we are definitely going to look at these random walks. We'll revisit these random walks and we'll answer many questions using Markov chain theory. So our next example would be simple random walk on finitely generated free group of random. So this will be the only non-commutative group example, random walk on a non-commutative group example that we will see. But before giving this example, I must say that this random walk on groups, this particular topic is a very important topic, not just in probability, it also is very useful in geometric group theory.